All right, so today for our warm-up, we're going to take a look at graphing quadratics and square root functions. So we're going to do a quick review over those. As we know, quadratic and square root functions are inverses. And so the reason we're going to look at this is because today for our notes, we're going to be graphing cubic and cube root functions, which are also inverses. So we want to look at those and remember what those relationships are and be able to apply them to two new functions today. So let's start with our quadratic function. We know that it's a quadratic because of this squared right here. So the first thing that we need to do for a quadratic function is to find that first most important point, which is our vertex. So remember that the numbers right here are going to give us our vertex, and we have to take the opposite of the one inside and same for the one on the end. So the opposite for the one on the inside would be a positive 3. And then on the end we have a positive 1 and it stays the same. So our vertex is positive 3, positive 1. Now remember that those same two numbers are also going to give us two of our parameter changes. We are going to have a third, and we'll talk about that in a minute. All right, so let's go ahead and get that graphed. So we have our vertex is at positive 3, positive 1. And then, remember for our quadratic, we have a pattern. So it's 1, 1, 2, 4, 3, 9. Because 1 squared is 1, 2 squared is 4, 3 squared is 9. So remember that this is going to be right, and then this is going to be up. Now, the problem is, though, is that we have this negative in the front. So that means our second part of the pattern is not actually going to be up, it's going to be down because of the negative. All right, so we're going to go right 1, down 1. And then remember that parabolas are symmetric, which means you should also have a matching point over here. So we go left 1, down 1. Then our next one is over 2, down 4. So over 2, down 1, 2, 3, 4. And then matching point on the other side. So from our starting point, we're going to go left 2, down 4. All right, remember you are always, always, always counting from that starting point. All right, then for our last one, it's over 3, down 9. So starting from the starting point, we're going to go over 3, down 9. And then from my starting point, over 3, down 9. All right, so there is our parabola. And we can connect those dots real quick. All right, so once we have our graph, then we can go ahead and get all of the attributes or the characteristics of our function. So we have two x-intercepts. We have one here and one here. So the first one is 2, 0. And then the second one is 4, 0. Our y-intercept is right here. And so that's going to be 0, negative 8. Alrighty, our domain for any quadratic function is negative infinity to positive infinity because it goes left forever and right forever. However, our range is not. Your range must go bottom to top. So on the bottom, we see that it goes down forever. So that means our range must begin at negative infinity. And then it only goes up to positive 1. So our range ends at positive 1. Now remember, when you're doing domain and range for these functions, the number gets a square bracket, infinity always gets a parentheses. All right, now for our parameter changes, we have 3 of them. So we have our negative in front, reflects over the x-axis. And you have to tell me that it reflects, and you have to tell me that it's reflected over the x-axis, because we can reflect over the y-axis. So therefore, we need to make sure that we state that it's reflected over the x-axis, not the y. All right, the other two parameter changes are going to be these right here. So our numbers are -3 and +1. So inside is horizontal. So I'm going to say that's a horizontal, and I'm just going to put H for horizontal. So it's a horizontal shift. And then remember that this is opposite, so that minus is really going to the right. So that's a horizontal shift, right 3. And then the +1 is our vertical shift, and since it's plus and it's same, that's up. So that's going to be a vertical shift, up 1. All right, so there is our quadratic function real quick. Let's take a look at our square root function, which we know is an inverse of the quadratic. Now we had to be careful with the square root and quadratic functions when we did our test in our quiz in Unit 4, because we know that a square root function is only half of that sideways parabola. So when we did these, sometimes we had to add that restriction on the domain. So what's nice about our cube and our cube root function is we're not going to have to worry about that, but we'll see that in a minute. Let's go ahead and get our square root function done. So the first thing we do is find our starting point. Remember that a square root function does not really have a vertex. That's the starting point. So our starting point is going to be the opposite of that +4, and that -3 is going to be the same. So opposite would be -4, same would be -3. So there's our starting point, -4, -3. All right, from there, we can use our pattern for the square root. Now remember, it's the inverse of a quadratic, which means our pattern is going to be 1, 1, and then instead of 2, 4, it's 4, 2. And then instead of 3, 9, it's 9, 3. So remember that this is going to be to the right, and this is going to be up, unless we have a negative in front. There is no negative here, therefore it is actually going to be up and not down like before. So from our starting point, we go right 1, up 1, then go back to your starting point and go right 4, up 2, then go back to your starting point and go right 9, up 3. And so then we connect our dots, and then we can fill in our characteristics. So our x-intercept, well, we only have 1 this time, and it's going to be right here at 5, 0. And then our y-intercept is going to be here where it crosses the y-axis. So that's going to be at 0, -1. Our domain for a square root function is not going to be -infinity. So remember, domain has to go left to right. So on the left, it only goes out to -4. But on the right, it goes forever. So that's infinity. Remember, the number is going to get the square bracket. Infinity gets the parentheses. Now we're ready to look at our range. Well, range has to be bottom to top. So for our function, it goes down to -3 on the bottom. So that's where it begins. And then it is going up forever, not very fast, but it is going up forever. So that goes to infinity. Number gets the square bracket, infinity gets the parentheses. Now for this one, we only have 2 parameter changes because there is nothing in front, so there's no parameter change there. The only parameter changes we have are these 2 things right here. So our +4 is opposite, so that's really -4 or -4. So that would be a horizontal, and remember, horizontal is left or right. Since this is opposite, it is actually going to be left. So it's a horizontal shift, left 4. Then we have our -3. Since that's outside, it's vertical. So it's going to be a vertical shift, and vertical is either up or down. Since this is -3, that's going to be down 3. All right, so that is a quick review over our quadratic and square root functions, which are inverses. So now we want to take a look at our two new functions for today, which is cubic and cube root. And these are also going to be inverse functions, so we want to keep in mind the relationships between that. So inverse functions, remember, are going to switch x and y. So once we find the points for one, we're able to just switch x and y to get the points for the other. So let's start with a cubic function. We're going to get our basic parent function, and then the transformations are going to work exactly the same as all the other transformations we've done. We're just going to have a new parent function to start with. So let's take a look at our parent function for the cubic. All right, so cubic is x cubed, which means we're going to take all of our x values and we're going to need to cube them, which means multiplying it by itself 3 times. So that's going to be the same thing as whatever x is times that same number again times that same number again. So 3 of the same thing multiplied together. Now, as far as what x can be, we want to think about that first. If we're taking something times itself again, what kind of numbers can and can't we include? Well, we can definitely multiply positive numbers together, 3 of the same thing, and we'll get a positive. We can take 0 and we can multiply it together. 0 times 0 times 0, that's still going to be 0, so that's possible. What about my negatives? Well, if I take a negative times a negative, I get a positive. Then times a third negative, I'm going to get a negative, but it's possible. So that means that x can really be anything. So that right there tells me that my domain is going to be -infinity to +infinity. And what's really nice about the cubic function is that it is always going to be that. Your domain is never ever going to change even after the transformations. So we're going to go ahead and plug in real quick -3, -2, -1, 0, 1, 2, and 3. Now, since this is cubed, our numbers are going to grow much faster than they did for the squared function. So if I'm doing -3 cubed, remember that means -3 times -3 times -3. Well, the first two -3's multiplied together are going to give me a +9. But then when I multiply it by that last -3, that's going to give me a -27. All right, well, that's great, and that is a point on my function. However, it's not going to fit on my graph, so I'm not going to bother with that one. It is still a point, it just won't fit on our graph. All right, then we want to take -2, and we want to do the same thing. So we're going to have 3 -2's multiplied together. So if I take -2 times -2 times -2, well, the first two together give me a +4, and then when I multiply that by that last -2, it gives me a -8. Okay, so we've got that one. Now let's take a look at -1. If I do the same thing with -1, -1 times -1 times -1, the first two -1's multiplied together give us a +1, then times that last -1 gives me a -1. Well, 0 is easy. 0 times 0 times 0, well, that's just 3 zeros multiplied together, so that's just going to give me 0. All right, now how about 1? Well, if I take 1 times 1 times 1, well, that's just going to give me 1. Then if I do 2 times 2 times 2, well, the first two give me 4. Then times 2 gives me 8. Then 3 times 3 times 3, well, the first two give me 9. Then times that last 3 gives me 27. So again, that last point, 327, is technically a point on the graph, but since it won't fit on the graph that we're given, we're not going to bother to use it. So we're really just going to use the -2 to +2 points. So if I go in and I graph those, I always start with this point because this is kind of what I call my central or my starting point. It doesn't have a vertex, and you're going to see why when we graph it. So I start with that central point, 0, 0, and then I'm going to have positive 1, positive 1, and I'm going to have negative 1, negative 1. So I've taken care of these 3 middle points. And you notice they make a nice, neat little diagonal there. That's pretty much always going to be the case. Now I need to take my next 2 points. So I have positive 2, positive 8, and I have negative 2, negative 8. And so we get this long, skinny, drawn out graph. So that is our basic cubic function. Now, this is why we don't have a vertex, because it's not turning back up like a quadratic did. So there's no change in direction. Our graph is going to increase this entire time. It's always going up as we go from left to right. So there is no vertex. We just call that middle point our starting point or your central point or something like that. All right, so once we have that basic parent function graph, let's take a look at its characteristics. So we already determined that domain could be anything, negative infinity to positive infinity. I can take any number I want and I can multiply it by itself, 3 of them multiplied together. Now my range, once I get it graphed, I can see that it goes down forever and it goes up forever. Therefore my range is negative infinity to positive infinity. Now the really nice thing about the cubic function and the cube root as well is that since the domain and range are both negative infinity to positive infinity, that means they are never going to change, even after the transformations. Because if I take that graph and I flip it over, it's still going to go left forever, right forever. It's still going to go down forever, up forever. If I stretch it out, still going to go forever. If I shift it, it's still going to go forever. So you don't have to think very hard about your domain and range. It is always, always, always going to be negative infinity to positive infinity for these 2 functions. Now, if we take a look at our x and y intercepts, though, well, it crosses the x-axis right here at 0, 0. But that's also where it crosses the y-axis. So for the parent function, we have the same x-intercept and y-intercept. So those are both 0, 0. Now, once we start transforming, that may not be the case anymore. So let's take a look at how we transform. So up on the top, these are going to be our more complex cubic functions. So just like all the other functions we've done, this number in front is going to stretch or compress it. If it's negative, it will reflect it over the x-axis. Remember that would be 2 separate transformations. A reflection is a separate transformation from the stretch or shrink. Then the next one we have is whatever's here. So that's going to be your left or right shift. So it's going to be a horizontal shift, either left or right. And remember that this one's going to work opposite. Then our last one is going to be whatever's behind the function. So that's going to be our vertical shift, either up or down. And this one keeps the same sign. So if we take a look here, we're going to use the patterns to graph these just like we did for our quadratics and our square roots. No, so our pattern then, if we look at what we have right here, we notice that the numbers kind of follow the same pattern. We've just got positive on one side, negative on the other. So we don't change anything for the 0, 0 as far as our pattern goes, because that's going to be our starting point, our central point. What we need to use for our pattern is going to be 1, 1, and then 2, 8, because 1 cubed is 1, 2 cubed is 8. So remember that this is going to be right and left. This is going to be up and down, okay? So remember, your basic parent function goes like this. So unless you have a negative here, then it's going to follow that same pattern. If you've got the negative, it would flip it over to go like this, but we don't, which means that's going to be our shape that we have when we're done. So let's start with our starting point. We know that this is going to be opposite. which would be positive 2. This is going to be the same, so that's negative 1. So if we have positive 2, negative 1, that's our starting point. So then, if our starting point is here, then we want to go right and up, and then we also want to go left and down. So we're going to start with our 1, 1. So we're going to go right 1, up 1, put our point. We're also going to go left 1, down 1. So we've got those 3 points right in a row there. Then, be careful here. Remember, from the starting point, we're going to go right 2, and then up 1, 2, 3, 4, 5, 6, 7, 8. And then from the starting point again, so from here, we're going to go left 2, and then down 1, 2, 3, 4, 5, 6, 7, 8. Oh, let me change that back to pink. All right, so there is our function. And we can now fill in our attributes or characteristics. Well, the domain and range are always going to be the same. Don't have to think about those very hard. Our y-intercept. We can see from our graph that it crosses the y-axis right there. So that's going to be at 0, negative 9. Oops, 0, negative 9. All right, our x-intercept is right there. And so that's going to be at 3, 0. Okay, now our parameter changes. Remember, our options are reflect over the x-axis, a vertical stretch or shrink, we have a horizontal shift, and we have a vertical shift. So we have nothing in front, which means that there is no reflection, there's no stretch or shrink. The only thing we're looking at is these two right here. So the negative 2 is opposite. We know that that's going to be a horizontal shift, and since it's opposite, that's going to be to the right. So we have a horizontal shift, right 2. Then that -1 is a vertical shift, and since it's negative, it's going down. So we have a vertical shift down 1. All right, so that is our cubic function transformed using that pattern. Now, if you prefer transformations, they do take more time, but it can be done. So if I had wanted to do this with a transformation, I could take my original parent function here. So those are my original parent function points. And then we know the parameter changes are we need to shift right 2 and then down 1. So if I take my first point here, right here, and I shift right 2, down 1, I get that new point. Take the next one, right 2, down 1, right 2, down 1, right 2, down 1, and right 2, down 1. And I get the same function that I did using the pattern. So which way you choose to do is up to you. Both ways should give you the same function. All right, the next one we want to look at is number 2. Now let's start off with our parameter changes because we actually have 3 this time. So we have, our first one is the negative in front. We know negatives in front reflect, and since it's in front, it's going to reflect over the x-axis. Alrighty, then our next one is this +4, and remember it is opposite. So since it's inside, it's horizontal, which is either left or right. And since it's opposite, that +4 is really going to the left. So that is a horizontal shift, left 4. All right, Then our last parameter change is that +1. This one is going to be vertical because it's at the end of the function, and the sign stays the same for this one. So since it's plus, that means it will be up. So this is a vertical shift, up 1. All right, so we have our parameter changes out of the way. Let's go ahead and get this thing graphed. Now remember, my central point or my starting point is going to come from here. So opposite would be -4, and then same would be +1. So -4 and then +1. So there's my starting point. Now, I know that my pattern is going to be that 1, 1, 2, 8. However, we know that's right and left. We know this is up and down. But remember that we have this negative in front, which means that we actually want to go the opposite way. So our function is now going to go like this. So if I'm going to follow that pattern then, well, I know I need to go right 1, but instead of going up this time like I did originally, I need to go down. Then I'm going to go the other way, left and up, 1, 1, and I get those 3 points right in a row again. Now I need to do my 2, 8. Remember that we are starting from the central point, and we are counting right 2, down 1, 2, 3, 4, 5, 6, 7, 8. And then from that central point, we're going to go left 2, and then up 1, 2, 3, 4, 5, 6, 7, 8. All right, so we have our points, and we can go ahead and connect them. So then we still have that same basic shape, but it's upside down compared to the parent function, and it's shifted left and up. So that gives us our graph. So remember, a positive cube function will go like this. A negative cube function will go like this. Okay? All right, now, domain and range never change. So we keep those both, -infinity to +infinity. My y-intercept, well, it crosses the y-axis. Oh, hey, I don't have a y-intercept on my graph. Now, I know that it's going to have one because it goes forever in all 4 directions. So how do we figure that out? Well, we know that in a y-intercept, one of those coordinates has to be 0. So if it's going to cross the y-axis, then that means that the x-coordinate has to be 0. So I know that's going to be 0. My question is, what is y? So that's what we're going to find out, and we're going to do it algebraically. So if I take my function and I make the x-coordinate 0, that gives me y equals negative, parentheses, and instead of x, remember we're making that 0, plus 4, cubed, and then plus 1. Now we have to make sure that we follow our order of operations. So the first thing we do is parentheses. So we need to go ahead and take care of that 0 plus 4 in the parentheses. So that gives us negative. And remember that this is really a -1. So I'm going to go ahead and put that so we remember that we're multiplying. And then within the parentheses, 0 plus 4 is 4. It's still cubed, and we still have the plus 1 at the end. Now after parentheses, we have to do exponents. So we have that -1. And then 4 cubed, if you put it in a calculator, is 64. Because remember, that's 4 times 4 times 4. So the first 2 together give you 16. Then 16 times 4 is 64. Then don't forget we still have that plus 1 at the end. Well, -1 times 64, because multiplication is next, is a -64. Then we have to add the 1. And so y equals -63. So that's a big number. Well, actually a really small number. So that gives us -63 is the y. So we now have our y-intercept. Now our x-intercept is nice and easy to see because it's actually on the graph right there. So it goes left 3, so that's negative 3. It does not go up or down, so that's 0, negative 3, 0. All right, so that is the cubic function and how to transform it. The next thing that we want to look at is the cube root function. Alrighty, for our cube root function, it's going to work very similar. Now we have to remember that a cube root function is the inverse of a cube function. So we can take those points that we got for our original parent function for cube, and we can simply switch the x and the y. So let's go back and take a quick look at what those parent function points were. So we're not even going to bother with the negative 3, negative 27, because we already determined that doesn't fit on our graph. So I'm not even going to bother transferring it over. But I'm going to take these points right here, and since I know the cube root is the inverse, I'm going to simply switch those. So the negative 2 through positive 2 is going to become my y's, and the negative 8 to positive 8 is going to become my x's. So let's go over here. So our y's are going to be negative 2, negative 1, 0, 1, and 2. And then we're going to have our negative 8, negative 1, 0, 1, and 8. So those are going to be the points for my cube root function. So let's graph those. So let's start with the starting point here, 0, 0. Then let's do the ones. So we're going to have positive 1, positive 1. We're going to have negative 1, negative 1. So those first 3 points are exactly the same as the cubic function. Where it differs is those outside points. So instead of going like we did in the cube function, right to up 8, and then left to down 8, we're switching those. So we're going to go right 8 up 2, and then we're going to go left 8 down 2. So notice it has the same shape, but it's sideways. So you guys have got to be able to remember, cube is the one that's going up and down. Cube root is the one that's going left and right. Okay, so cube root is tall and skinny, and then cube root is wide. All right, so cube, tall and skinny, cube root, wide. All right, so let's take a look at our domain and range. So since it's the inverse of a cube function, then that means the domain and range would switch, but they were the same anyway. So again, for the cube root, we don't have to think about it. It is always going to be negative infinity to positive infinity. And then for the parent function, well, that's both my x-intercept and my y-intercept. So those are both going to be 0, 0 again. All right. Now, we're going to have a very similar pattern for this. So our pattern, remember we don't bother with the 0, 0, that's our starting point. It's going to be 1, 1, but instead of 2, 8, it's 8, 2. So this is going to be our right and left. This is going to be our up and down. So the first thing we want to do is get our starting point. So our starting point is given to us by these two numbers. So the one inside is opposite. The one outside is the same. So our starting point, opposite of minus 1, is going to be positive 1. So that's positive 1, negative 2. So there's our starting point. Now if we follow our pattern, 1, 1, 8, 2. So there is nothing in front here that would change my pattern. There's no negative, there's no number, so it's not reflected, it's not stretched, so we can follow the pattern just like normal. So remember that this is a positive cube root, so it's going to go like this, just like the parent function did. If there was a negative in front, then I would have to flip it over. So I know that from the starting point, I should be going right and up, and then I should be going left and down. So right one, up one, left one, down one. There's those first 3 points that are pretty much always going to be the same. Then, from the starting point, I count right 8. 1, 2, 3, 4, 5, 6, 7, 8. And then up 2. And then from the starting point, I count left 1, 2, 3, 4, 5, 6, 7, 8. And then down 2. And so then there is our function. Oops, I missed my points, but it's okay. All right, domain is always going to be negative infinity to positive infinity. Range, same thing. All right, let's take a look at our intercepts. So we have a y-intercept that is right here. So that is going to be, let's see, x would be 0, and y is down at -3. Then we have our x-intercept is right here. So that is over 9, up 0. So 9, 0. Now my parameter changes. So remember, your parameter changes are anything in the function other than the cube root and the x. So that's going to be our -1 and our -2. Remember that -1 is inside, so it's a horizontal shift, and it's opposite, so it is actually going to be to the right. So we have a horizontal shift, right, what was it? 1. All right. Then that -2 is behind the function, outside, so that's going to be a vertical shift, and it keeps the same sign, which means it is going down. So we're going to have a vertical shift down 2. And those are our parameter changes. All right, so that is our first transformed cube root function. Let's take a look at another one. And we've got something a little bit different in this one. So we have 3 parameter changes. We need to be very careful here. Remember, the negative and the 4 are 2 separate parameter changes. The negative is going to reflect over the x-axis. And then the 4, since it's in front of the function, that is going to be a vertical stretch. So we're going to have a vertical stretch by 4. Not a compression, because 4 is bigger than 1. Now, if this had been 1 over 4, then that would be a compression by 1/4. But since it is bigger than 1, it is a stretch. Then our third parameter change is going to be this +1, which is inside. Therefore, inside is a horizontal shift, and it is opposite, which means that +1 is really going to the left. So it is a horizontal shift, left 1. All right, parameter changes are taken care of. Now, let's get it graphed, and we're going to have to be kind of careful here. So we can get our starting point. Well, we know that the inside is going to be opposite, so that's going to be -1. However, I don't have anything out here, which means it is the same thing as having +0. So there is no vertical shift. So the +1 becomes -1, it's opposite, and then the understood +0 is going to be the same, so that stays 0. So our starting point is at -1, 0. Now, when we go to do our pattern, this is where we need to be careful. So we know that our pattern is 1, 1, and then 8, 2. So right and left, up and down. Now I need to be careful. It's a negative, which means it's reflected. So that right there tells me that my function is going to go like this instead of the other way. but it also has to get stretched. Since it's a vertical stretch, that means that you are multiplying the vertical component by this -4. So if I multiply this by -4, then that means that you are going to be going right 1 and then down 4. And then you're going to be going right 2, down 8. And then remember, you're going to go back the other way. So we're going to go right and down. And then once we finish that, we're going to use those same numbers, but we're going to go left and up. Okay, so from here, we're going to go right 1, down 4. And then we're going to go right 2, down, what was it? Down 8. Nope, I wrote some stuff down wrong. Sorry. Okay, back that up a second. All right, so these, 1 and 8, there we go. And then 1 times -4 is -4. 2 times -4 is -8. There we go. Okay, got the pattern fixed. All right, so we're going to go right 1, down 4 is good, but then we need to go right 8, down 8. So right 1, 2, 3, 4, 5, 6, 7, 8, down 1, 2, 3, 4, 5, 6, 7, 8. Okay, now back the other direction. Now we need to go left and up. So we're going to go left 1, up 4. So left 1, up 4. And then we're going to need to go left 8, up 8. So left 8, up 8. All right. Now remember, our function is supposed to look like this, right? Just stretched out. So it's going to go from the side, and then it's going to curve through our points, and then curve and go out to the right. Okay, so there's our basic shape just stretched out. So our domain, -infinity to +infinity, range is the same. Now my y-intercept. So the y-intercept is right here. So that's going to be 0, -4. Then our x-intercept is going to be right here, which is -1, 0. And we've already listed the parameter changes for that, so that one is good to go. Sorry about that mess up there. Alrighty, then the last problem that we need to do is taking this function and simply listing the parameter changes, the transformations. So remember, transformations and parameter changes is the same thing. So we need to first determine how many we would have, and there are going to be 4 parameter changes here. The negative, the 3, the +5 inside the function, and the -8 outside the function. Each one of those is a separate parameter change. So if we start with the negative, well, that's going to reflect over the x-axis. Then, next we'll do the 3. So the 3 is bigger than 1, which means it is a vertical stretch. And since it's a 3 in front, it's a vertical stretch by 3. So vertical stretch by 3. All right, so there's 2 down, 2 to go. Now, the +5 and -8 are our shifts. Remember that inside is going to be your horizontal shift, either left or right, and it is opposite Therefore, that plus 5 is really going to the left. So that is a horizontal shift, left 5. And then we have our last one, the minus 8. Since it is behind the function, it is a vertical shift, and that one keeps the same sign, so that minus 8 is going down. So that is a vertical shift, down 8. All right, so once we have the pattern for those, and we understand kind of how the pattern works, those are actually pretty quick and easy to graph. You do need to be careful when you have to do a stretch, because those are a little bit easy to get mixed up, so be careful there. Other than that, I'm thinking hopefully we should be good. So go ahead and get your assignment done and submit it on Canvas, and then I will see you next time.